Hi, my name is Tejas. I don't actually need to tell you how to pronounce it here because we're all Indian and this is great. Yes, give it up for India. Fantastic, amazing. I am a developer relations consultant or DevRel consultant. And what that means is I work with a lot of developer-oriented companies to help them have really good relationships with developers. Past, present, and future, I tend to help them reach people and have great relationships with them. If you're interested in DevRel, come find me after. I'd love to talk about DevRel with you, including what that means for your company. But that's not what we're here to talk about today. Today, we're here to talk about React Server Components. React Server Components. This is a very exciting topic because it's new. How many of you are familiar with the Flux architecture here? Okay, a good amount, I'd say half the room. The Flux architecture essentially states that you have a view that dispatches actions through a dispatcher to update a store or a state storage that then updates the view again. It's also represented by this function v equals f of s, or view is a function of state. This Flux paradigm, this Flux architecture is the thing that React kind of championed in its time. So in this way, we can kind of arrive at the conclusion that React is an architecture. But above and beyond that, there's tooling that React popularized. Front-end architecture and infrastructure became more popular with React over the years. JSX was pioneered by React, and it got a lot of pushback, right? We were rethinking best practices. They said, wow, they put HTML and JavaScript. It was very weird. And with that came a lot of new architectural tools. For example, we never used Babel as much as we did until React became a thing, right? And then suddenly we're transpiling code. We're writing Webpack configurations more so by hand. And around the time, we had tools like Gulp and Grunt, et cetera. So we did have certain architecture and infrastructure tools, but React, I would say, made them more prominent. And with that, React is an architecture. If we consider how we used to write React like 10 years ago, we've all written this, I'm pretty sure. We would start with npm install react DOM, right? We'd start with this. This is pretty normal. But then the developer dependencies, npm install -d, Babel, Webpack, dev server, Babel preset env, Babel preset, it doesn't even fit on the screen. Just a lot of dev dependencies. And the point I'm trying to make is 10 years ago, the tooling required to get up and running with React was really complex because it wasn't mature. We were figuring it out. It was hard to be onboarded to React. Indeed, that is the criticism today. Libraries like Vue, for example, you can just include a script tag with unpackage.com and you start writing. 10 years ago, the tooling wasn't mature enough to support it. React today is way easier. npm install react DOM, npx vite, you're good, right? The tooling has matured so much that it kind of disappears. I often forget it's even there, right? Because it's matured 10 years later. Now, this is important for you to know because React Server Components is in that early stage where React was 10 years ago, okay? That you need certain tools to enable React Server Components, but these tools are not mature enough. You need new bundlers. We'll talk about why. You need new routers. We'll talk about why, okay? These tools are considered next generation tools and they don't yet exist, although there's work being done to create them, okay? They're new tools. So I want you to keep that in mind. The tooling is immature. That's why RSC is so unapproachable for now. It will get better over time, just like React did, okay? But while we're on the subject of RSC, and indeed that's the point of this talk, the topic of this talk, what is RSC? What is React Server Components? You could answer this in many ways, no doubt. You could say it's a way of executing components on the server side and then sending their rendered output to a client, to React on the client side. Client-side React picks it up and continues. This way, you don't ship a lot of dependencies that your project depends on, things like date functions or markdown, usually large problematic dependencies. You just ship the output of those dependencies. So hypothetically, you're shipping less code. You could also define RSC as a better way to do data fetching through async components. Some would say RSC is just suspense for data fetching in a new way. Okay? In many ways, I want to define RSC together, you and me, with one long sentence, okay? And so a lot of people would say, hey, don't go on your phone and be distracted. I would say pull out your phone and tweet this sentence, because it's a large sentence broken up into many parts, but I do believe it encourages us to think about RSC in the right way, okay? It goes like this. Let's take a big breath. React Server Components is first and foremost an architecture. React Server Components is an architecture that beautifully marries client and server for various benefits. But we'll start there. React Server Components is an architecture built on next generation tooling. as in next generation bundlers, next generation routers, and including next generation server mechanisms. Okay, you need all of these. So it's an architecture built on next generation tooling that is still experimental and not production ready. This is very important that you don't go use this in production. In fact, I'm not here to teach you how to use React Server Components because that's changing every day. It's a work in progress. I'm here to teach you the underlying, are you trolling me right now? The underlying mechanism of how it works. So not how to use it, but how it works so that you can take this with you to work and enhance your understanding of React and JavaScript knowledge. So it's still experimental, not production ready, that requires rethinking React. So React started as a client-side only library. This is a fundamental change to React where it's server first, not server only, server first. So we have to reorient the way we think, such that we rethink our interaction boundaries. We rethink the way we do context. There's a lot of rethinking required for the benefits, but the benefits are worth it. Okay? So it requires rethinking React that includes the server at every level of the virtual DOM. This is really important, because so far, if you're server rendering your React application, what you're doing is you're rendering one page probably at the server, sending that page to the client, and then the client takes over. The server just does, it's like a one-trick pony, just does the page and goes. With server components, you can include the server anywhere in the tree, not just at the top page. So you can have one component that's server rendered, client, client, and then another server rendered component, et cetera, just as you need. So you can remove heavy dependencies and do the work on the server. You can also do secure transactions on the server, like data fetching from your very private secret database, because it's on your server. So you can choose what runs where in any point of the tree. That's very important. So it includes the server at every level of the tree, and this unlocks tremendous benefits, like we talked about: security, performance, less code, et cetera. Ultimately, it unlocks these benefits for data fetching, for performance, and for better user experience. Better user experience because things are going to be faster and more smooth. Now, if that's not clear, we'll build a demo and we'll look at all of this together, but that's the sentence. If anyone can say the sentence back to me after the talk, I will be very, very proud of you and myself. But let's talk a little bit about how it works, and then we'll build them from scratch. How React Server Components work. I'll show you this with a little diagram of a React tree. So this is a React tree you should be seeing. Okay? The top node, the blue nodes, they run on the server, on my server. The yellow nodes run on your device, the browser, the client. And this is kind of the way to think about RSC. The blue things are server, the yellow are client, such that the blue things run on my infrastructure, the yellow run on yours. The blue things can read from this laptop. The blue things can run on my database securely. The yellow things run on your browser. And there's certain things that I can do in the blue that I can't do in the yellow. For example, I can read from the file system on the blue. I can't import FS into your browser. Okay? I can read your time zone in the yellow. I can respond to your click events in the yellow. I cannot do that on the server. So they both complement each other. Server components can import client components because they're serverful, and you can work with that. For example, you can split a client component out into a module reference and lazy load that on the client. You can't do this in the client. Client components cannot import server components because if they import FS, they don't know what FS is. They don't have the Node.js runtime. Okay? How it works is when you server render a root node, and that then encounters a client component, what the bundler does, and this is why we need a next generation bundler. What the bundler will do, it will recognize, hey, this is a client component, throw a directive use client at the top. Then when it encounters a client component, it will split that out into a client bundle, separate JavaScript file, and replace this in what it sends and what the server sends to the browser. It will replace this with a reference to the module. So instead of actually including the module, it will include a string that refers to, hey, here's the file, go lazy load this on the client's device, execute this on the client. That's what the yellow is. The yellow is not actually the client component, it is a reference to the client component that is then loaded and executed on the client's device. Does that make sense? Yes? Great. So you think about it this way. Server components run on your server. Client components, through a bundler, become references to a client component that the client will download and execute. Okay? That's very important for you to understand. Let's talk about how this fits into client-side rendering, that's CSR, server-side rendering, that is SSR, and static site generation, that is SSG. Okay? And we'll do this through a diagram. CSR, client-side rendering, is probably the worst way to do React today. For the vast majority. For internal things, for mock-ups, et cetera, it's maybe useful, but if you're building something to production that you want a wide amount of users to use, client-side rendering is probably your worst bet, because the user's browser will have to download HTML, first of all. Okay? Download the HTML. It's pretty cheap. It's fast. But then the HTML is going to refer to JavaScript. JavaScript. Then it needs to go download JavaScript. OK, download JavaScript. Then it needs to parse the JavaScript. Then it needs to execute the JavaScript. All of this takes time. And depending on the device, you have no control over the device. It could be a small, old mobile phone. And it's going to take time. Once parsing and executing is done, you need data. So then you reach out again to the network, get some data. Maybe there's no internet. So a lot can go wrong. A lot is slower. And CSR is really not the best for things today. That is to be used for a lot of people. Again, it has its place. But for the vast majority, I would say CSR is pretty not ideal. So let's evolve. Server-side rendering is great, because you can fetch your data on the server. You can render your components to strings, HTML strings, and you just send that once. So your client, the browser, downloads everything one time, and they're ready, including data. It's great. There is one performance cost of hydration. Hydration means making everything interactive, attaching event listeners and stuff. But compared to client-side rendering, this is way better already. Also, search engines can read this because you're sending processed HTML, whereas search engines probably will have a hard time reading client-side stuff. Okay, so SSR is great. How does React Server Components fit into the server-side rendering model? Are they the same? Are they different? They are very different. So if we add React Server Components to server-side rendering, what you need to think about is this. There are actually two servers, two backends. You have the SSR backend that renders your React page to HTML, sends it to the client. That we know. Okay, that we've been doing for years. There's also an RSC, or React Server Components backend, or server, that renders your React tree to a React Server Components tree. It executes the async components, unwraps everything, and hands it off to your SSR backend, which then further processes things and sends the HTML string. Okay, so the RSC backend is more or less first. And in this context, your SSR backend, your SSR, server-side rendering server, is actually a client of the RSC backend. Okay? So when you say use client, it means anything that consumes RSC, including a server. So the server is the client. If this is confusing, it's fine. We'll actually look at it in some code in a minute. Similarly, if you want to do static site generation, same thing. The React Server Components backend is consumed by the static site generator, and then it's used for static output. Okay? So the RSC backend is its own discrete unit that speaks to other clients, including servers that generate sites. Okay? I've reached the point in my presentation where I'm bored by myself. I've talked too much, and I would rather just show you some stuff. So what we're going to do in our remaining time is build an app using React Server Components from scratch. If the audio cuts out, I love you all, goodbye. But in any case, let's just start building this application. So if I come over to the laptop, what we have is this, a website that shows you a list of dog breeds. Anyone like puppies? I love puppies. Okay, like, I don't know, 10% of you love puppies. The rest of you will figure it out. So this is a thing that shows you a list of dog breeds. Husky, I love huskies. So you click on husky, and you get taken to, wow, beautiful. And you click on this to go back, okay? The problem with this is, there's many problems with this. Problem number one is it's client-side rendered. So if I view the source of this, what are search engines going to see? There's absolutely nothing. There's just a bunch of script text. This is what Google will see. So it will not really see the words to index my site. Also, I need to download all this stuff, et cetera. It's really complicated. So client-side, already a problem. Second, the navigation, there is no really good router. What I mean by that is when I navigate to another page, say I enter my name, Teju Kumar, okay? Now, if I click on a link, my state gets blown away. You see that? It should persist. So I enter something. This is really bad. Also, this rotating dog, it kind of resets when I navigate. So I'm literally lose my state between navigation. That's pretty bad. We need a smooth experience. I think we can maybe illustrate this a bit more, but we'll get to that. So this is the problem. So how can we enhance this? Number one, let's just add server rendering. We just talked about server rendering. It's going to give us a lot of benefits. Let's do that. We'll build a server. But before we do that, let me show you the code. So we have index.tsx. This is a classic React entry point where we're hydrating the document or rendering on the document the layout component. Okay, that's kind of what we're doing here. If we look in the layout component, we have HTML, head, body. It's just a classic layout, really nothing special. We have the header with our rotating dog and everything. And then in main, we have children. Okay, what is children? Well, children is, we have a simple router here. So if we're on /list, then we show the list component. Otherwise, we're on the detail component. Okay? What is the list component? The list component is something that holds dog breeds and images. You can see the breeds here and the images in the background in state. We fetch the breeds. and we set them in state. It's fetch, then set state. Basically, we should have written this at some point in our career. If not, we can learn not to do this, okay? And then we return some JSX. So you can actually see that. Welcome to my dog site, welcome to my dog site. Here are some things, right? And then we map over the list. So this is the list. The detail page is very similar. So again, we use effect, fetch, then set state, and we return. That's this, okay? So good. I hope we understand. What I want to do is add a server to this. So we go from client-side rendering to server-side rendering first because of those benefits, okay? This shouldn't be very hard to do. What I'm going to do is I have a file here, server.tsx with nothing. I will import React from React. I will import Express. Express is my server of choice. You can use whatever you want, Fastify, I don't really care. And we need this function, render to string, from React DOM server. This is going to take our components and turn them into an HTML string that we send to the client, okay? So let's instantiate our server. We'll say app is Express. What we're going to do is app.use, just the root route. We get request and response. And what we're going to do is respond. So we'll const HTML is we'll render to string. But what do we render to string? We need our layout. So we'll get layout. And we need, sure, we need a router. So we'll do the path. We'll get the path from here. And we'll render this to the string, and then we'll res.end HTML. But layout needs children. How do we get children? Well, we can do something called file system-based routing. So we have pages, detail, and list. So based on this, we'll render. So what we'll do is we'll say this is an async function, and we'll const page is await, and we'll dynamically import, okay? So we'll import from the process's current working directory, dist, oops, no comma there, dist pages, and then rec.params.page. Okay, so we're just dynamically importing this. That's .path. Oh, TypeScript is awesome. Okay, fantastic. So we're dynamically importing the page, and once we do that, we'll get the component as the default export. So const component is page.default. And then we just render the child component, whatever it is, list, detail, we don't care. And for props, we'll use query params just for fun. So we'll spread rec.query as props. Layout needs another prop, which is background color, BG color. So we'll say BG color is white. Looks good so far. So we're rendering here. The next thing to do is listen on a port and expose the server. So we'll app.listen, port 3000. Sure, we're listening on port 3000. Save. So basic, we have a simple server. This is nothing complex. Let's go and run the server. So what I'm going to do is npm run build and start the server. And now if I go to localhost 3000/list, we should see this. We don't have any CSS. That's pretty ugly. So let's fix that by exposing app.use, and we'll expose the static directory. So we'll say express.static dist. Okay? And this will just give us access to some nicer style sheets. So now if we reload, perfect. We have it, but there's no data, unfortunately. There's no data because we don't have React on the client side. So we'll just include the client bundle, client.js, just like this. We'll rebuild the server, restart. And now we have React on the client side. It's great. It kind of works just as it did before, except we have a little bit of server rendering. If we look at the source code we get from the server, what we see is there's some text involved. There's RSC thingy. It's no longer just script tags. There's the input. There's server time. There's a lot of things. But we don't actually have the data. We don't have the list of dogs on the page. So search engines are not going to see the list of dogs. We're still kind of missing out. This is where we need data fetching. And this is indeed what server components are for. We can include data fetching in many different ways. We can use suspense. We can use get server-side props. We can do a lot of things. We will use server components. We're going to implement server components from scratch to understand how we can use them for data fetching. Okay? So this is the server component part. I hope you're ready. Are you ready? Nobody's ready. That's cool. I'm not even ready. So what we need to do to enable server components is let's go to our list component. And we need to what if we could get rid of all this use effect, use state stuff, and do this? So we say this component is async. We'll change its type to any, just to make TypeScript happy. And instead of all of this use state stuff, we just go here, delete all of this, and say it's just await. Boom. Wow, look at that. So much simpler. And then we can do the same for the other piece of state. So we'll say const images is await this. And look, we can get rid of all of this. Oh my goodness, amazing. And the best part of server components, check this out, check, look, watch. Oof! Come on. Amazing. So we have a new type of component, an async server component. This is a server component, okay? And it just uses async. This is the magic of server components. Now, how does this work? let's first build the server and see what happens. So we'll kill it, we'll rebuild the server, and we'll go access port 3000. Oh no, everything broke. What do we see here on the server side? A huge error. So our React renderer says, hey, I found a promise. I don't know how to render a promise, help. And we need to teach React how to render promises. We need to create an RSC backend, a React server side thing that gives us a JSX tree that we then give to a client. The client in this case is React render to string. It's the server. The client is the server, okay? So we'll create a way to almost serialize this tree of React. So what we need is, we need to take this JSX, let's go to the server. We need to take this JSX, this layout and stuff here, and notice it's HTML. So JSX just returns, this function returns more HTML, or it can return a string, it can return a Boolean, it can return anything, right? So we need to take this JSX tree and turn it into something that React clients, like the server renderer or the client renderer, can understand, okay? So let's do that. What we need is a big function with a lot of if-elses, because it can be strings, it can be Booleans, it can be anything. So we'll do that. We'll say it here, const create RSC tree. It takes JSX and does something with JSX, okay? Let's start really simple. If there's no JSX, we return null, which is valid. If it's a string or a number, or a Boolean, what we can do is .includes type of JSX, exactly. Then we'll just return it, because this is also valid. If it's an array, like children, we will iterate over it and just return it, okay? But we want to be async about it, so we'll await. Instead of just iterating, we'll await promise.all, like this, okay? Next is the fun part. So if it's a object, here is interesting, because React elements are just JavaScript objects. I did a talk about this once called Deconstructing React. They're just JavaScript objects. And they look like this. For example, this JSX here, div ID hello thing, right? This is in React is basically this. So you have type div, props is ID hello, ID hello, and children is string, kind of like this, right? This is what that becomes, okay? So if the type is a string, meaning it's a built-in component, or it can be a function component like this. This is now a function. Type can be either string or a function. So we need to handle both those cases. So before we do any of that, we need to first identify that this object is in fact a React component itself, okay? We do that using the type of property. So if JSX.$typeof equals symbol.for React.element. This will tell us it's a React element. Once it's a React element, we have to handle it if it's a built-in component that is a string or a function component. So JSX.type, if it is a string, then it's a built-in component. So we'll handle that. If it's a function, we'll handle that separately, okay? So if it's a string, what we need to do is we just return the JSX, but we map over the props with our create RSC tree, like this. That's it. If it's a function component, we actually get the component, which is type. So we'll do JSX.type. We get the props. It's JSX.props. And then we get the rendered output. So we'll say rendered, and we'll just call component with props. Now keep in mind, the component is async, so we'll await it. And then we return await create RSC tree on the rendered output. We're just going deep, 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 and rendering as we go. There's no chance of finishing this in 5 minutes. And then, so lastly, if props are an object, we need to also recursively work on them. So what we'll do is we'll return. We'll get the props first as keys, so entries, and we'll say JSX. And we'll basically map over them. We'll get the key, the value. We'll destructure that. And we'll return exactly the same tuple, but we will do this. We'll create an RSC tree. We'll await the RSC tree from there. This, of course, then needs to be async, which means we need to promise.all. So this gets really complex. And lastly, since we're object.entries here, we want an object back. So we'll from entries, the await, object.fromEntries. So what we're building is a React Server Component parser. And this is what we have. This is kind of going to give us a React Server Component tree, okay? So now let's get that tree. So we'll say const RSC tree, exactly. But what we'll do is we'll just take what we're giving to the server renderer and instead give it to the RSC tree, like this, okay? And we'll just take the tree and give it to the server renderer, okay? Now I want to show you what we get, because I think this is really interesting. So instead of sending HTML to the client, I will send the big JavaScript object we just created So we'll JSON stringify RSC tree null2. And I want to show you what this actually gets. So we'll rebuild our server, and we'll reload the page. And what we should see is just a big JSON object, right? This is our React tree, but rendered server components. And you can see there's a lot of data here. For example, all the dog breeds are here. There's Affenpinscher, African, etc. So this object now, React on the server side and on the client side needs to pick up and render, okay? It can do that. So if we, instead of returning this tree, we return HTML, what we should see, let's kill the server, restart, is, wait for it, right. It gets replaced immediately because the client side doesn't know how to handle this. We'll delete the client side script. So this is server-only server components, okay? Reload. There we go, we have it. So the data is fetched on the server, we're rendering this on the server, and it's pretty great because if we view source now, we actually see the output, including all of our data, all of our dog breeds. You can see Shar-Pei, sheepdog, etc. Okay? I want to do one more thing, because if we click here, it still crashes, and that's because we didn't update our detail page. So we'll turn this into an async. This is the best feeling in the world, just kind of replacing all this stuff with async await. Okay? Just like that. No set state as well. That's kind of all we need to do. Save. And we'll restart the server now. Right? And OK, we need to tell it this is any, because TypeScript doesn't know you can have async components yet. So we'll reload. And just like that, we get the detail page, we get the list page using server components rendered exclusively on the server. Fantastic. So that's your introduction to server components. There's a lot more to do here. For example, we need to add client-side stuff so you don't lose state on navigation, etc. There's a lot more to do, but that should give you an intro to server components. How it works is you build an RSC backend that can understand promises and things, that can execute asynchronously, and you pass it to a client. The client can be a server. The client can also be a browser. Okay? I hope that's clear. Let's move on. I want to give you 3 practical tips for how you can adopt server components, or how you can approach adopting server components, how you can put yourself in a good spot to take advantage of server components. Number 1 is fetch data early. You want to fetch data as early as possible. If you can, definitely outside of use effect. If you really can, at the server side level is going to put you in a really good spot to adopt RSCs incrementally. Number 2, you need to reconsider your interaction boundaries. Because oftentimes we have event handlers inside large components. You have a component with a title, content, button, onClick. This onClick should be in its own file, maybe one line, right? Exclude your onClicks as much as possible. Your event handlers will put you in a good state for React server components. That way you can render as much as possible on the server and as little as possible on the client, which is better, usually, because it means your users have to download less. Number 3, we probably use React context in our applications. Servers don't have the same context as browsers. But what servers do have is server-side cache. So if you can move some of your context into server cache, maybe namespaced by a user for personalization, is going to put you in a good spot to adopt server components, because all of this is serverful. Okay? I'm about to end, but I want to share with you one final thought, which RSC is a lot of things. It's an architecture, it's whatever. We talked about this. But above and beyond that, React server components is a community effort. And I'm looking around the room. We are the React community. Okay? So it's going to take all of us to actually want and be excited about this. Moreover, React itself is a community effort. And we are the React community. And unfortunately, we haven't been the best community lately, especially around server components. There's been discourse that's been a little bit hostile, and it's caused a lot of us, a lot of the React team even, to be like, I don't really feel this. And that's on all of us. And I feel like in calling this out, my desire is that we recognize it and we're able to do better and be the community that we want to be and the community that React deserves. Okay? So in summary, we talked about a lot of things. We looked at server components on the server. We looked at how they work. We talked about React as an architecture. We talked about community. We talked about a lot of things. There's way more we can do, including implementing client-side rendering and really creating that smooth navigation state. All of that is on my YouTube channel. You're welcome to scan the QR code, subscribe, like, etc. There's also new content like that pretty often, so I'd invite you to join that. As well, this is a 2-day event with some really great talks, and I get the honor and privilege of being the first one. But what I want to do is recommend you go to all the talks, because they're all great, but I want to give you some talks that are related that touch on similar topics. So the next one by Mateusz and the others from, for example, Pulkit or Dani, they talk about server-side rendering, and they are pretty adjacent to this one. So I'd encourage checking those out if you can. With that, React Nexus, I want to thank you so much for having me. It's been an absolute honor, privilege to be here.